Hi guys, so today we're going to be discussing Leetcode question 876, middle of the linked list. So the question is, given the head of a single linked list, return the middle node of the linked list. So let's say this is an example that we have, an odd length linked list. Odd length linked list means the number of nodes in it are odd length. Okay, so since this is 5 length node linked list, so this is an odd length linked list. So in this case, what is the middle node? It is clearly seen that this is the middle node. And if we have an even length, let's say an even length linked list. So let's say, for example, this is what we have. So in this case, these two are the middle nodes, right? So the question specifies if there are two middle nodes, return the second middle node. So this would be our answer. So how do we compute this? So again, we're going to be using fast and slow pointers approach for this. So how does this approach work here? So let's say we have a linked list, something like this. Right. So we'll initialize our slow pointer here and a fast pointer to the next of slow pointer. Once we have initialized, all we have to do is, this is what we have to follow. Just a moment. Slow pointer is equals to slow pointer dot next, basically increment slow pointer by 1, and fast pointer is equals to fast pointer dot next, basically increment the fast pointer by 2, as long as they are valid. So how do we go about this? So let's say in the first iteration, since we can move slow pointer ahead, it's a valid move, so this becomes slow pointer, and fast pointer changes from here to, which move further to 2 positions. So this is the new fast position. We can still move ahead, right? So slow pointer becomes this, since it moves by 1 step, and fast pointer goes to next and then next. So the next and next. So basically fast pointer reaches here, null. So now notice the positions of slow pointer and fast pointer. If you notice carefully, our slow pointer points towards the middle node, right? So in this case, our slow pointer is our answer. So case 1, if we have an odd length linked list, so the answer for that would be slow pointer is the middle, right? Now what if we have an even length linked list? So let's say if our example is something like this. So let's say this is what we have. 1, 2, 3, 4, 5, 6. This is an even length linked list, right? So now we initialize slow pointer here, slow pointer, and fast pointer to the next of slow pointer. This is the initialization step. And again, as discussed earlier, what is our motive? To increment slow pointer by 1, that is, move slow pointer every time in every iteration to its next position, and fast pointer by 2 positions. So fast pointer goes to its next position. So let's do a dry run of this. So this is the initial step. Since we can make valid moves, so slow pointer moves 1 step ahead and fast pointer moves 2 steps ahead. So 1, 2. So it comes here. Next, slow point, we can still make valid moves, right? So slow pointer from here moves 1 step ahead. So this is the new position for slow pointer. And fast pointer can also move 2 steps ahead, right? So from here, it moves 2 steps ahead, 1, 2. It comes at the node 6. So this is the new position for fast pointer. Notice that we can still make valid moves for slow pointer, but the fast pointer has reached its end since it cannot move 2 more steps ahead. So this is where we stop now. So notice that since this is an even length linked list, we have 2 middle nodes, right? What does the question suggest? If there are 2 middle nodes, return the second middle node. So basically, if our slow pointer, as in previous case, was pointing to the middle node, so if we assume that slow pointer is still pointing to the middle node, then its next node is what you have to return in the case of an even length, if there are 2 middle nodes. So case 2, even length linked list, or should I say 2 middle nodes. So in that case, slow pointer dot next points to middle node. Now that you've seen the dry run of both these cases, so what is the actual algorithm? So the algorithm is, after the initialization step, we keep looping as long as we have valid pointers. What does valid pointer means? Slow is not null. Slow pointer is not null. Basically, we can move slow, right? We can operate on slow. It points to a valid node. Slow pointer is not equal to null. And fast pointer is also not equal to null. And we can at least move 1 step ahead for both slow and fast pointers. So fast pointer dot next is not equal to null. This ensures that slow pointer can also move and fast pointer can also move at least 1 step ahead. The idea of using fast pointer is to move 2 steps ahead. So its next step is valid and the next step of that can be null. So that is not essentially invalid. And what was our base algorithm? This was our base algorithm. Slow pointer is equals to slow pointer dot next, move by 1, and fast pointer is equals to, since till here we had a valid move, now we move it to the next pointer of that. So this is what we have. And then in the end, if fast pointer has reached a null position, right? So return slow pointer. Why? Because when fast pointer has reached a null position, so basically this case, an odd length case, so we were returning the slow pointer because that was pointing to the middle node. So this is essentially odd length linked list. But let's say if fast pointer dot next is equals to null, not the fast pointer but the next pointer of it. So in that case we return slow pointer dot next. Why? Again, as we saw here in even length case, when fast pointer is valid, fast pointer points to a valid node location but its next is invalid, right? So in that case we have 2 middle nodes and we return the next pointer of the slow pointer, which is exactly what we're doing here. So this essentially means even length linked list. So this is the complete algorithm for our approach. I hope you guys understood this video. I hope this helped you understand the question. I hope you guys liked the video. Please feel free to leave your comments in the comment section below. I'll attach the link to the complete GitHub code in my description below. Hope you guys enjoyed it. Have a nice day.